got the time. It's delta V divided by the acceleration.
That give you the time.
You can get the time from this.
But it's another way you can get the time too, right?
Which way?
Didn't you do it the other way?
The time is the distance. If you put the time here, the time is the velocity change divided by acceleration from this one.
Okay.
Right? So yeah, so if you put this into this formula, you will put T1 into this formula, and then you can get this one is equal to 25.9.8. And this T, we can also calculate the total time. Because when it reached the maximum, we just said the velocity is 0, right? So the time is 0, the initial, minus the initial time.
We have to do that?
Yeah, we need the total time also.
It just seems very flaky.
It's very complicated.
Yeah, okay, so now go from this part here.
From here?
Yeah, we just do the calculations?
Yeah, it's just you need to do the calculations. Yeah, if you put this into here, so in the end you have two formula and you have two values to determine.
I'm not understanding how you get the answer though.
This one is one I got a wrong answer. I don't know if it's maybe there is another way to calculate. Let me see.
Then the rest of them you had the right answers?
Yeah.
Okay, keep moving. And then at the end, if we have
Well,
time,
maybe
we'll come
if we
back to
have
it.
Yeah. Next one. At t equals to 0, a particle leaves the origin with a velocity. The rest of the questions is like you need to separate them to x-axis and y-axis. At the initial velocity, so everything you need to separate them into y-axis and x-axis. Okay, the initial velocity was 9 meters per second in the positive y-axis. So the velocity y initial was 9 meters per second. And there is the initial velocity along the x-axis was 0. Okay? And then the acceleration, ax, was 2, and ay is 4 meters per So the question is asking you when the instant that the x coordinate of the particle is 15 meter. So it moved 15 meter here. It moved 15 meter. That's all we have when we read the question. So what is asking you is the final speed, the speed of the particle. Okay. The speed of the particle will be, in the end, we can got velocity like this, or velocity here. That's the final velocity, is the addition of these two velocity. So essentially you want to calculate the final velocity along x and the final velocity here, right? The first thing we need to determine here is how long when it reach 50 meter. To calculate this, r equal to the time that's 0. Here is 0. And here is 2. So here is 15. So t square root 15. That's the time. And the final velocity in the x-axis will be, according to the formula, axt. You got this? And along the y is the same. ayt. So you will get two numbers here, right? And then just the final speed will be
You take the square root, once you get the velocity in the x and the velocity in the y, you take the square root of the both. And that would give you the answer, right?
yeah, the square and then plus and then square root. Okay.
That was for 23.
So this one is 23 and the answer is 8. 10 meter per second.
Okay, 24.
24. Particle starts from origin 0 with velocity of basically the same thing. We can put into x and y. So the initial x is 16. Initial y velocity along y-axis is -12. And the acceleration it also gave to you. On x, 3. On y, -6. It's asking you what the speed at time equal to 2 seconds. So what we need to do is to calculate here the final velocity is initial velocity plus ax times t, which is 16, 3 times 2, which is 22. It's just this formula, right? And here is the same thing.
You need another marker.
Yeah, this one is me. Let's see. This one. Oh, the meter is 12 plus oh, it's negative 12 times 2, which is negative 24. So
That's the velocity
that's
along the y.
along the y. So in the end, it's got 22 and then 24. Okay. So the final, the addition will be this one. That's the final speed. They ask you what the speed, it will be square root and if you calculate it will be 33 for this question. You got this one?
25.
25